Hello everybody, I'm Dan. Welcome to my Java and Raspberry Pi programming tutorial series. The order in which my tutorials are organized on both my website at pijava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is basically, we're going to do the Land Cruiser speed control using JNI, Java Native Interface, C++, and the Gpio library. Let's go ahead and open up my website, pijava.com. We'll select Pi Programming. We'll scroll down to the JNI C++ speed control. Don't confusing it with the steering one here. Okay. And so in this tutorial, I will demonstrate how to use some simple functionality of the pigpio library, the pigpio library, to control our electronic speed controller, ESC for short, on GPIO pin 18. Now, GPIO pin 18 is the one and only pulse width modulation pin, and it seems like a good idea to demonstrate how to control it in this tutorial. I will be using Java Native Interface, JNI, along with C++ and pigpio to control the ESC. So basically, the GPIO pin 18 is right here. Our steering is going to be off of 23, so that's basically the way that's laid out. This time I'd like to talk a little bit about ESCs and how they work. Let's go ahead and open up my, let's see, we don't want that, we want this here. Okay, so I've got my car kind of ripped apart here. And originally this thing came with a speed controller, here it is over here, this thing right here. And I gotta say, I wasn't particularly pleased with this particular thing here. In order to set it, you have to like press this button and then look for little changes in LEDs and stuff like here. The problem with it is when you're pressing this button, your finger tends to cover up these LEDs. Plus this LED goes from like green to whatever. But anyway, didn't particularly like this thing. Could only get it to work in like braking mode and forward. Never got the reverse to work. Spent way too much time on this thing. So what I did is I went and bought another one on Amazon here, and the one that I bought on Amazon here is it's much better because it has, first of all, just little jumpers where you can set everything there, right? Bottom jumper is basically for a lithium battery versus a nickel metal hydride, and let me move the camera up in here. I'll just refocus this a little bit here, so you guys can kind of see what I'm talking about there. Okay, so got this jumper right here, and then this jumper over here, and makes it really easy to configure this thing. So basically, I've got the jumper set to crawl mode, which is another cool thing because I want this vehicle to be able to kind of go slower, not it's kind of getting these weird spastic movements out of that other ESC. And it just wasn't really all that good. So coming into the ESC, here's basically the way it's wired up here. We've got our battery pack here, right? And that plugs right into there. Had to get a little adapter for it though. Fortunately, the battery pack came with that. And then, of course, we've got the big thick red wire and black wires that go right out to the motor, right? And you'll need to have those hooked up for the electronic speed controller to configure properly there too, by the way. So just keep that in mind. Don't try to turn it on and expect it to do much of anything without these two hooked up. Next, we've got just a simple little on-off switch here, right? And then we've got these three wires coming out of the ESC, which is red, black, and white. Okay. So the black is our ground, the red is a hot, and it's actually what it's doing is it's outputting 6 volts, okay? So don't plug any power into that necessarily, right? And then the white one is basically the controller wire there. Okay, so I've got my voltmeter set up over here. I'll twist this up here just a little bit so we can see that just a little bit better on that, and pull this out just a hair. Okay, refocus this. Okay, so what I'm going to do is I'm going to go ahead and switch on the, and it makes a little beep there, right? And you can see we've got 6 volts coming out of there now, because basically I'm just tapping right into there. So that's just important to know that you have output voltage there. And what that output voltage is actually designed to do is typically power a receiver and a servo there. And later on I'm going to use that hot wire to actually power the servo that's in here. 6 volts is plenty for that one, even though it's rated up to like 8 point something or other. I tested it out and it works just fine. Okay, so it beeped once, and then we've got this little blinking on the LED, so it's like I don't see any sort of signal coming across. So we're going to go ahead and code that up here. But before we do, I am going to let's turn this guy off, and let's get the voltmeter out of the way, and let's hook up the Raspberry Pi real quick here. So. Alright, so I am going to come over and skip the first 2 pins, right, and hook this up to the 3rd pin, and then I'm going to skip 2 more pins. Pop that off. 3rd pin, skip 2 more pins, and put the communications wire on Gpio 18. Okay, so twist that in just so you guys can kind of see that going there. 2 pins on, 2 pins off, and then onto the skip. Yeah, anyway, let's pull up the diagrams here so you guys don't get confused on that. So we're dealing with, we're coming across these pins here, so we got the ground on there, and then we skip 2 more pins, and here's Gpio 18. Okay, so that's the way that's configured there. Now, all we're doing is we're sending a signal across, so we do have to have that ground wire there. So I'm going to plug the ground into the black wire there, and the white one here that I got coming off of 18, which is going to be our communications line into the white on there. Okay, so that is basically how that looks. All right, now we are set to go ahead and compile our program and start running the thing there. Forward, braking, and reverse. All right, I'm going to go ahead and minimize this. And remote desktop into my Raspberry Pi, and I've got that on the wrong screen right at the moment. Okay, I've already got this up here in the screen so we can cut and paste some code here. So the first thing we'll do is just pull up in the terminal here, we'll type in cd java, right, and then cd land cruiser. And I'm going to leaf pad esc.java, be the name of our source code file, also known as our compilation unit. Let's go ahead and come down here and highlight. Highlight the code. Back up. Copy and paste. All right, first things first, let's come up here and save this. I'm going to talk a little, actually, you know what, let's just run it first, then I'll talk about how all this is going to work here. So let's go ahead and close out of that, and we're going to compile this here. Java C esc.java, right? We're going to compile that, and then we're going to create our header file using Java H. So if we do a dir right now, right? We've got all our stuff there for the steering, the RC server, so you've definitely want to been following my tutorials. If you're just popping into this one, you might want to definitely head back to bare minimum to where I walk you through installing the JNI, the Java native interface stuff there. So we've got our ESC, our compiled bytecode there, a class in Java, and now we're going to say Java H minus JNI and ESC for the class that we want to do that for. Okay, and now we do a directory here. We got our esc.h right here, so that's all good there. And now what we're going to do is we're going to leaf pad esc.cpp for our C++ file there. Okay, let's come down here, grab this code here, we'll copy and paste this. And come up and save it. And let's go ahead and compile that now. Oh, I'm going to close out of it first. All right, so we're going to do G++ minus shared, and then minus I for the first include location there, which is home, pi, and then JDK, and then include, right? And then our next one there, minus uppercase I for the next include path there, home, pi, JD, I'm hitting tab, by the way, to cruise through these things, and then they need this Linux folder here. Okay, and we're going to be compiling the my alarm just went off there, so my phone. All right, let me just check something real quick here. Sorry about that interruption. I just want to make sure. Yep, good. It didn't interrupt that. Okay. esc.cpp, right, and -o for our output will be lib.esc, always prefixed by lib, and esc.so for the library. And we need to tell it about the pigpio library there. Okay, look for that. All right, we'll go ahead and hit enter on that, and that compiled successfully. So if we do a dir now there, right, or actually just do an lm, or just do dir. We've got our lib.esc.so right there, and so that's basically our compiled library there. So now we're ready to go ahead and run all this here. I'm going to go ahead and hit clear to clear the screen off, and then I'm going to need super user do there and Java, and we need to tell it where the location of the library is, even though it's in the current folder there. So java.library.path equals dot, and then we are going to be running the ESC, invoking the ESC class there. Okay, so let's go ahead and move this into a smaller screen over here. Let's pull back up this here, make it just a little smaller, and maybe turn my Pi that way just a little bit there. Okay, I think I like how I got it all set up now. All right, so what we're going to do is I'm going to go ahead and come over here and press enter. Okay, now I've got, I think I set up like 15 seconds to turn this thing on. So you'll hear a beep and then a longer beep, and now it's kind of configured there. Okay, so as you can see, as our stuff is going over here, the wheels are now spinning faster. It's getting a lot louder. And as we get up here towards like 80,000, it'll start slowing down. And then when we get to about 110,000-ish, it'll go ahead and stop. And then now, as it starts climbing, you see the wheels will reverse. And then they'll get really fast. Like about 140,000 is where full reverse is. And then they're going to start getting there. And I'm going to hit Control-C right around 110,000, which is kind of our neutral. That's actually right at around a 111 there. So. But, whoops, I missed it. Okay, so I'm just going to break out of that and run it again there, so we get to our stop there, and then break that. Okay, so let's talk a little bit about the source code now. All right. In the first, well, actually, we'll talk about the C++ library there, right? So we've got our esc.h, we created that using the java h command. I've got this function here called gas pedal, right? And of course it takes, the first two parameters are always going to be in there. But then I've got the pin, the hertz frequency, and the duty cycle, okay? All coming in. And as you can see, I'm displaying those to the console using the printf C++ method there. We always initialize the Gpio library first. That's part of the PI-Gpio here, right? And then I'm using a new method here called Gpio hardware pulse modulation, right? And then pin, it'll always come in as 18 from the program there. And hertz is set to 74, and I'll explain while I'm doing 74 hertz. And then our duty cycle is a value that's basically translates into pulse width of neutral is about 1.5 milliseconds all the way down to like 1.1 millisecond for the full forward and 1.9 milliseconds for full reverse. And I'll show you how I came up with all those numbers there and the math behind it. Okay, so let's come back up here to the main code here. And I'm doing, in these first three statements here, I'm setting the neutral, the forward max, and the reverse max. And you're probably looking at these numbers going, what on earth? But I'll explain it all here. So, basically, hold on, my snooze alarm just went off again. Sorry. Okay, so the hertz is 74. And what I did is I hooked up Futaba, a remote control there and controller, and just hooked my scope in there, and I just looked at all the signals that were coming across there, and basically it was sending a 74 hertz signal. So, and then various different values on the millisecond stuff. If you guys are interested, shoot me a line in the comments there saying you want to see that video there, and I can hook up the controller and then show you the scope, and we'll scope it out and show you how I came up with that. But anyway, as we know, there's 1 hertz equals 1 second, right? So we take and there's 1,000 milliseconds in a second. We divide that by the number of hertz that we want to get. In this particular case, it's 74. It gives us a 13.5 millisecond period, right? If you remember back to my other tutorials, previous tutorials, the period is, excuse me, hold on. Grab something to drink. The period is the time when the signal goes high, in other words, max voltage, to when it drops and right before it goes high again, say. So we're going to end up with 74 of those per second there, which gives us our 13.5 millisecond period. Okay, so we need the neutral to be about 1.5 milliseconds. So if we take 1.5 and divide it by 13.5, we end up with 0.1111. That goes on to infinity, but I'm just rounding that down to thousandths there, right? So then we take that number times 1 million, and I can go into that in a future tutorial and why the 1 million is there when I go over pigpio a little bit more. But anyway, that gives us 111,000, right? So that's the duty cycle that basically comes in here. And same thing on the math, 1.1 divided by 13.5, 0.81 times a million, 81,000, and so on and so forth. So when you saw these numbers going, up and down, that's where they were going from. They were going from the forward max to the forward reverse in steps of basically 50. Okay. Here is the native method gas pedal, right, and passing pin, hertz, and duty cycle to it. And here is the static block where I load in the ESC library, right? And you remember it's prefixed by libe and then esc.so is what it's looking for on that load library. Okay. In the main method entry point here, I'm just creating a reference variable of type ESC, that's our current class, and then I am invoking the gas pedal method, passing in our pin 18, which is the pulse modulation pin, and the hertz that we want to do, 74, and then the neutral position there. I'm calling this thread sleep 10,000, 10 seconds basically, so that we can get the unit powered up and turned on. So you run the program, then you turn on your electronic speed controller, so it's already got the signal going on the electronic speed controller, and then at that point basically you got 10 seconds till it will invoke the test full range method, which is simply starts off in the neutral position, and then it keeps invoking the gas pedal method while stepping down basically 50, okay, and then sleeping 20 milliseconds in between that. And once it gets to the forward max, right, then it'll reverse and set going down false, and then it'll go back up. So it'll oscillate between all of that there. Okay, that pretty much covers that. I'm going to go ahead and just we don't need that anymore. I'll just run this one more time to show you guys there, and let's do a up arrow on that, right? Okay, enter on that. And come over here and turn this guy back on. Oh, he actually is still on right now. So, in a little bit, that'll just start doing its thing there. All right, let's go ahead and cycling through. So, there we go. Now we're coming back up. Now we're going reverse. right down there. Yeah, I'm going to go ahead and hit Control-C there. Close enough, and I am going to turn this guy off here. Okay, I don't have a lot of like error handling and stuff like that in this whole program yet, which I will be adding basically later on there. So it's still putting out pulse signals to the out the GPIO right now, you know, even though we don't have this here. So you can do one of two things for now. Just go ahead and do a reboot there. You can either come up here to start, shut down, and, you know, select shut down, or you can just do sudo reboot. Nice little command from the thing there, and that'll reboot the Raspberry Pi and reset the GPIO pin ports to closed and stuff like that, where they are by default. Anyway, so I think that pretty much concludes this tutorial. Thanks for watching.